Hello everyone. Welcome back to the AWS Certified Solution Architect Associate Certification Bootcamp. In this session, we'll explore all the concepts related to EC2 auto-scaling for the AWS Certified Solution Architect Associate Certification. We'll start by understanding what an auto-scaling group is and then see how it works with a load balancer to distribute traffic smoothly. Next, we'll explore the important attributes of an auto-scaling group. Then we'll look at scaling policies and how you can use triggers and metrics to automatically adjust your resources when demand changes. Finally, we'll cover the concept of cooldown periods which help prevent unnecessary scaling. By end of this video, you will have a clear picture of how auto-scaling group keep your application running efficiently and how to prepare for this topic in AWS Certified Solution Architect Associate Certification. Let's start with what is auto-scaling group. An auto-scaling group contains a collection of EC2 instances that are treated as a logical grouping for the purpose of auto-scaling and management. Auto-scaling group manages EC2 instances automatically and it can adjust the number of servers based on the application traffic. Let's understand with a diagram. Let's assume we have our user and our application is deployed using EC2 servers. Currently, the application is observing steady state traffic and the application is served using two backend EC2 instances. Now, as you are seeing more and more traffic, auto-scaling group will add one more EC2 instance in the backend target group, some more traffic, one more EC2 instance to handle the additional load, some more traffic, it will add one more EC2 instance to handle the traffic influx. Auto-scaling group will help you to manage the number of servers to serve your traffic optimally. Now once the application will start seeing reduction in the traffic, auto-scaling group will automatically reduce the number of instances from the backend target group. Lesser traffic, it is going to reduce one more instance. And this is how auto-scaling group will automatically increase or decreases your backend servers based on the application load. You can perform the scaling operation based on the metrics like CPU usage or network traffic. Auto-scaling group works with launch templates or launch configuration. We have a dedicated slide to explain launch templates and launch configurations where we'll compare both the concepts side by side. Auto-scaling group ensures high availability and fault tolerance. Now let's review benefits of auto-scaling group. Auto-scaling group will automatically handle traffic surge or traffic spikes. With auto-scaling group, you no longer need to assume capacity and you can avoid keeping your expensive IT resources idle. It will reduce cost by removing unused instances. It will also improve fault tolerance and reliability. For AWS Certified Solution Architect Associate Certification, please remember auto-scaling group is high availability plus cost optimization. Now let's review different attributes of auto-scaling group. Let's assume that we are hosting our web application using EC2 instances and we need only two EC2 instances in two availability zone, which is going to give us high availability. And with two EC2 instances, you can handle the night time or the off-peak hours. But during the average business hours or to handle the steady state load, you need two more instances. And as load will increase to your application, auto-scaling group will keep on adding the instances up to a certain point. Now let's understand this capacity, and there are terminologies to define this capacity. To manage your baseline capacity, auto-scaling group uses minimum capacity. Minimum capacity is the lowest number of EC2 instances your auto-scaling group will ever run. This is important because during off-peak hours, AWS will start removing instances from the auto-scaling group, and at one point of time the EC2 instance count can come to 0, which will create an outage to the application. Even if the demands drop to 0, AWS will not go below this number. Minimum capacity is used to ensure there is always enough baseline capacity for your application. For our example, our minimum capacity is 2. That means our application will always have at least 2 EC2 instances running, even during the very low traffic or off-peak hours or during the night time of the application. We also talk about the EC2 instances to handle the steady state load, and it's called the desired capacity. In AWS EC2 autoscaling, desired capacity refers to the target number of EC2 instances that an autoscaling group aims to maintain. Desired capacity represents the ideal number of instances the group should have running at a given point of time to handle the steady state application workload. You can set the desired capacity manually, or you can also adjust automatically through scaling policy. For our example, desired capacity is 4 and the autoscaling group will launch or terminate instances until exactly 4 instances are running. For the AWS certification, please remember desired capacity cannot be lower than minimum capacity. We also discussed that autoscaling group will keep on adding the instances up to a certain limit, and that limit is called maximum capacity. Maximum capacity is the highest number of EC2 instances your autoscaling group will allow. Even if the traffic spike beyond this limit, AWS will no longer launch additional instances. The maximum capacity will help you to keep control on cost, and it will prevent over provisioning. For our example, our maximum capacity is 8. Even during the peak traffic, autoscaling group will not exceed 8 instances. Now let's combine the concept of autoscaling group, load balancer and health check. Load balancer and health check we have already reviewed in our previous video, and let's understand using this diagram. Let's assume we have our user and our application is exposed via application load balancer, which is nothing but a type of elastic load balancer, and we have our autoscaling group, and at any point of time your application has 2 backend EC2 instances. Now as user is trying to access the application, user's request will be intercepted by the application load balancer, and then the application load balancer will distribute the traffic to the autoscaling group. For our example, we have minimum capacity equal to desired capacity, which is 2. That means at any point of time, our application will have at least 2 backend EC2 instances. Elastic load balancer can also perform health check on the backend EC2 instances. No matter if you use application load balancer, network load balancer, or even legacy classic load balancer, all can identify if any backend instances are not responding to health check or turns unhealthy. To maintain the desired capacity, autoscaling group will launch a replacement instance and kick out the unhealthy instance out of the target group. Now as application traffic spikes, to handle the additional load, autoscaling group will launch additional instances. Some more traffic, it will add one more instance. Let's assume we have maximum capacity of 4 and autoscaling group will keep on adding EC2 instances until the total count reaches 4. When you are launching new EC2 instances using autoscaling group needs to know exactly how to launch your EC2 instance in terms of what AMI to use or what OS version to use, which instance type, which security group, which key pair, and so on. Now instead of entering this information every time, you can store this in a template and you can use the template to launch your EC2 instances. AWS has 2 options to create that template. One is launch template and the second is launch configuration. Now let's review launch template and launch configuration in greater depth. We'll start with launch configuration. Launch configuration is the older approach. It stores all the basic settings you need to launch an instance, but it has limitations. Once you create it, you cannot edit a launch configuration. Please remember, for the AWS certification will try to trick you. Once you create a launch configuration, you cannot edit it. If you need to change, or if you want to change any attribute like AMI or the instance type, you need to create a new launch configuration to accommodate any update. Launch configuration only supports basic parameters and it does not support any advanced features. And please remember, AWS already deprecated launch configurations since December 31st, 2023. And if you go to AWS Management Console, you will no longer see launch configuration. However, some certification question sets still have answers related to launch configuration. In your certification, if you encounter any question with launch template and launch configuration, always choose launch template over any launch configuration. Now let's review launch template. Launch template is the newer version and recommended method by AWS. It has much more flexibility. You can create multiple versions so that you can update settings without starting from scratch, and it supports advanced options like spot instances, T2 or T3 unlimited instances, elastic graphics, and multiple instances type in a single autoscaling group. And you can use it for on-demand and spot capacity in the same target group. Let's review launch configuration and launch template side by side. I am not going to read all those attributes for you. However, you can see for recommended by AWS, edit after creation and other feature, launch configuration is always not the option, and that is why AWS deprecated launch configuration. And please remember to choose launch template over any launch configuration. Now let's review different scaling policies. If you are thinking what is scaling policy, a scaling policy is simply the rule book for when and how to scale. There are several types and you need to know all these types for the AWS certification exam. To start with, target tracking. Target tracking is the most common and easiest to set up. You can set a target metric. As an example, you can create a scaling policy and keeping the average CPU usage at 50%. Whenever your backend CPU usage will cross 50%, AWS will automatically launch a new instance unless and until you cross the maximum number of instances. Based on your target tracking, autoscaling will automatically add or remove instances to stay near that target, and it's much like a thermostat which is keeping a constant temperature inside your room. The next is step scaling. As the name suggests, here scaling happens in step based on how far the metric is from the threshold. As an example, you can create a step scaling. If the CPU is above 60% of average, you can add one instance. But if it will cross 80% and above, then add two instances. Step scaling is useful when you want more controlled scaling actions. The next is simple scaling. This is the older method, and here you set a single threshold and action. Like if the CPU is greater than 70% for 5 minutes, then add one instance. Please remember, simple scaling is less flexible than step scaling because it can only do one action per alarm. The next is schedule scaling. And if you know the traffic pattern in advance, for example, if you have high load every weekday at 9 am and between 9 am to 5 pm, then you can schedule scaling action ahead of time to match those traffic patterns. And last but not least, we have predictive scaling. Predictive scaling uses machine learning to forecast future traffic based on historical data, and it will automatically schedule scaling actions before even the demand happens. Now let's review how your autoscaling works, and we are going to explain the entire process using autoscaling group, scaling policies, just now we have reviewed, and CloudWatch. Let's take our previous example. We have the autoscaling group with a desired capacity of 2, and we have also created scaling policies. For this example, let's assume that we have created target tracking scaling policy, and we want to maintain an average CPU of 20%. We also have CloudWatch, and CloudWatch is like a sensor or a watchdog which monitors your servers or the EC2 instances and its metrics like CPU, memory, network, and all other parameters, and it can trigger actions when their thresholds are crossed. Now let's review how they all work together. Now let's assume CloudWatch sees a CPU spike and the CPU is above our threshold, which was 20%. CloudWatch will trigger the CloudWatch alarm. CloudWatch alarm will then notify the auto-scaling policy, and the auto-scaling policy tells the auto-scaling group to add one more server. Auto-scaling group will launch a new EC2 instance automatically to the auto-scaling group, or it will add in the target group to handle the additional load. It can also work in the reverse direction to remove that additional server. Using this mechanism, auto-scaling group will add or remove instances automatically based on the demand. Now before we conclude the video, let's review a very important concept, which is auto-scaling cooldown. Auto-scaling cooldown is a period of time after an auto-scaling action like adding or removing an instance, and during this time period no further scaling action will be triggered. The purpose of the cooldown period is to prevent rapid or repetitive scaling that can happen if the matrix fluctuates quickly. Let's understand with an example, and let's assume we have a target tracking policy where we are trying to maintain a CPU spike of 70%. Suppose our CPU uses spike above 70% and which will create a scale out, or which will add one more instance to the target group, and we have a cooldown period of 300 seconds. This will ensure that auto-scaling group will wait 5 minutes before considering another scale out event. Even if the CPU spike will be more than 70%, it will constantly check the cooldown period, and if the duration between the previous scaling event and the current scaling is less than 300, it is not going to launch an additional instance, which will ensure auto-scaling group waits 5 minutes before considering another scale out, and this will give the new instance time to start and stabilize so that the metrics reflect the real system load, not the temporary spikes. There are two types of cooldown. Either you can use default cooldown, which applied automatically to all scaling action, or you can use a custom cooldown. For the AWS certification, please remember, cooldown period is just like a pause button which will prevent overreacting to any short-term metrics changes. That wraps up this module. If you found this video helpful, please give it a thumbs up and subscribe for more AWS exam preparation courses and cloud certification bootcamps. Got questions or feedback? Drop them in the comment. We love to hear from you. Thanks for learning with us at Cloud Expert Solutions. You are now one step closer to crushing your exam. See you in the next module.